All right, so here in 25.2, we're going to continue our conversation about homeostasis. Remember, that's constant state. And we're going to talk about how we can continue to regulate that internal environment within ranges. And here we're going to talk a little bit about temperature. Okay. So, for example, if for some reason, if your temperature were to get too hot, whether it's an internal temperature because you're working out or the external temperature because it just so happens to be hot on the outside, there is a reaction that occurs that counteracts that temperature increase, where sweat glands produce sweat that exit through a pore, and that sweat will cover the surface of the skin. And as it evaporates, right, the idea would be that it would lower the temperature of the skin and therefore your body. So this would be an example of a way of maintaining homeostasis because it keeps your body from entering a state where it would be too warm. However, or also better said, there's a hair follicle with a muscle attached to it. If it gets too cold, often this muscle will actually contract. That muscle will pull on the hair. The hair will form a goose bump as it exits. And what will actually end up happening is this will help keep the heat on the surface of the skin so that the skin itself doesn't actually have any heat loss. And that's going to be another important way to help maintain this internal environment.
Still, bro.
In negative feedback, what you actually have is a situation where the reaction goes against the condition. So in this situation, we're describing breathing in terms of a negative feedback. So this person's going to hold their breath here, right? When they hold their breath, the CO2 level rises. And this is actually measured through how acidic the blood is. As the blood becomes more acidic, because of lactic acid production due to lack of oxygen, the body senses that and is like, hey, it's getting too acidic. Please speed up your breathing. If you consciously try to control that, right, your body's need to breathe will implore you to breathe more and more and more to the point where it's going to become very difficult for you to maintain that lack of breath. If you find a way to somehow override that sensation, you will eventually pass out, and then almost like your brain will reset and force you to breathe, even though you don't want to. So, if you were holding your breath in a competition and you convinced your brain to not breathe, well, great. Eventually, your brain will shut off, restart, and you'll breathe when you're unconscious. That's an example of a negative feedback because the process, the reaction to your CO2 level rising will decrease your CO2 levels in your blood. They go against each other. Positive feedback, on the other hand, is a reaction, but the reaction goes with the stimulus. So, for example, let's say you tear a blood vessel, you have some kind of cut in your skin or something. Uh, Clotting factor is released. Clotting factor are proteins that help build, well, a clot. Clotting factor, as it builds, will build the clot, and then that clot will overbuild. As that clot is made, more clotting factor is released. That clot is made, more clotting factor is released, and little by little, it eventually fills the entire ripped area. Another example of this is also breastfeeding. A baby, when they breastfeed, when they suckle, the more they suckle, the more they breastfeed, the more milk the mom produces, which makes the baby feed more, which makes her produce more milk, which makes her feed more, which makes her produce more milk, and the loop continues and builds on itself. That's a positive reinforcement or a positive feedback loop because the reaction to the event stimulates the original. And that is it for 25.2.